Okay, so tonight's meetup is about counting cars with drones. So basically, what we're going to do is walk through what you would need to do in order to get enough information, images, label those images, put them into a TensorFlow Lite file, and then put that onto an Android app, and then use a drone, in this case a DJI drone, to fly over a parking lot. And we're going to count cars and drones in real time. Okay, I just wanted to do a little bit on latest news this month. So, if you haven't realized, the DJI Android 5.0 SDK was just released. That provides support for the M30 and the M300, and hopefully the Mavic 3 isn't far behind. Mavic 3's been out for a while now. From what I hear, it's much more low level than previous SDKs. Something about making it, I don't know, making it open source now, so they've hidden a lot of their secret sauce. So yeah, that's what I'm hearing from my developers. Early indications are it's harder to use and much more low level. There's no iOS support, which is huge. So if you have an iOS app for DJI drones, then moving forward you will not see DJI iOS 5.0 SDK. You will probably see DJI 4.16.3 or .4 just for whatever bug support is going on, but it seems that if you're going to do drone development for DJI drones moving forward, then it's going to be for the older drones. You could do iOS, like the Mavic 2s, Mavic Minis, but the moving forward, there's going to be no iOS support for any of the new drones. Okay, so I just want to get back to, we're talking about doing counting cars with drones, and essentially what you're doing is you're using machine learning, but I wanted to go over just the basics in case you don't know, or you really don't, there's so much hype around the whole AI area. I just wanted to put some basic terms down. So AI is using computers to do things that would normally require some human intelligence. That's the Wikipedia definition, I guess. ML is a specific type of AI, so that's used to identify patterns and predict an outcome on large amounts of data. So the classic example would be predicting if you were male and in third class or steerage, would you survive on the Titanic? Assuming that we trained our ML machine learning model on data from the ship's manifest and survival records, chances are, if you're male in third class, what they used to call steerage, you wouldn't have survived. Basically what they're looking for is a child in first class or a female in first class would survive. There's some great YouTubes out there. There's some great Kaggle competitions all around the Titanic. It's worth looking at them, as especially a very good place to start if you're trying to learn about machine learning. So you basically have a number of inputs, and then you're trying to train the machine to guess what the outputs are. And then CV is computer vision, so that's replicating human vision, but with computers, which in our case is video from a drone camera. So what we're trying to do is have a pattern matching engine for cars, and then we're going to combine that with the computer vision from the drone, put the two together, and hopefully do some object detection. A lot of buzzwords. So the difference between machine learning and traditional programming is the traditional programming is much more like a cooking recipe. So you basically have a bunch of rules, and then you provide your data, and it gives you the answer. So I'm going to write my very, very functional code to say, here's what my recipe is going to be, and it's going to be the same every single time. Especially if you provide the same data. And then on the machine learning side, it's reversed. So basically what you do is you give it a whole bunch of answers and then ask it to try and figure out what the rules are. So we're reversing the whole thing. So in this case, what we're doing is we're giving it 5,000 images of cars and then drawing a yellow box around labeling. That's what labeling is, drawing a yellow box around a car in the 5,000 images, and we're using it to train it to say, hey, if we give you a picture of a drone that's taken from a drone flying over a parking lot. Can you tell us what the cars are based on what you've learned in the past? And that's what machine learning is. So in our drone example, we're going to be looking at counting cars in a parking lot. So what we do is show the computer a ton of images in the input layer. So that's this input layer here. And then also tell the output layer that, hey, this was a car when I was looking at a car. And we provide it with the answer in the hope that will give us the answer car when we show it a completely different picture of a car which it's never seen before. So I'm getting on an age a bit here, but I went to college we did a master's in the early 90s. Machine learning was all the rage for everybody. It was huge. Everybody thought that they were going to be writing neural networks and expert systems and not doing just standard programming. Didn't happen, and I think the main reason being is because these hidden layers required so much computer intensive capability, which we didn't really have at the time. So now we do. Same thing that people are using to mine bitcoins, same thing that people are using for really incredible graphics. You can also use GPU cards to do this very mathematically intensive machine learning. Essentially, it's just a ton of statistics that we're doing here. We're trying to say, machine learning is basically saying statistically, do you think this is a car? Essentially, that's what we're doing. And you also don't have maybe one or two layers. You have tons of layers. You have 20, 30, 40 layers that you're trying to do to get this to work properly. And also they talk backwards in what's known as a back propagation layer too as well. So the conversations are not just one way; they can be going back as well too to create a better statistical analysis on what you're trying to do, better machine learning. Lots of stuff we're throwing at you here. Also, AI and machine learning and drones can mean lots of different things too as well. So on the drone itself, typically if somebody's using AI, they're using it for obstacle avoidance. They may be doing some tracking, so that's the follow me thing. So basically you fire the drone up in the sky and say, hey, just follow me when I'm on my bicycle, and the drone will follow you and take some pictures that you can post later on your favorite social media. Or it could be navigation. So the drone will figure out how to fly in whatever kind of pattern that you're giving it. On a mobile app, this is what I'm really interested in, the machine learning part, is the real-time object detection, or image stitching and doing object detection after the fact. So but what we're really talking about today is just the mobile app stuff, the real-time object detection. So drones together with AI are good at counting, measuring, identifying things, reading text, vehicle license numbers, and it doesn't matter if what you're looking at is moving or not. So that's really where we're at in the mobile app space. And on the cloud, that's really taking all of the images that you took with the drone. So say, for example, it's flying a mission over a certain area, which would be a parking lot, and it's basically going to take all those images, it's going to stitch those together, and then it's going to tell you how many cars were in that parking lot, how many empty spaces. So it's object counting. So we do that post-processing, typically using a thing called OpenCV or ODM, Open Drone Map. I think I got that right. I'm hoping that in a few years I expect to see a large number of these outdoor and indoor manual tasks being automated by drones. So you think warehouses reading barcodes, that kind of thing. Most of the work it'll replace are mundane, labor-intensive tasks more suited to computers, and ultimately this will free up humans to do much more interesting work, rather than nobody likes doing inventory, so why not get a drone to do it, or a robot. So putting theory into practice. So this is what it looks like. This comes from, I think this was done, this was done using the app. So we're going to give you the code, we're going to give you the images, we're going to give you the TensorFlow Colab, and we're going to give you the code if you want to play around with yourself and see if you can create something else. Why are we doing cars? When we started off doing this, we were basically, I'm Irish, so I thought, well, we'll just count sheep. And then we struggled to find sheep footage. because I'm no longer in Ireland, and I don't live in I don't live in Kildare where all the sheep are. Um, basically, how can I get lots of images to teach people how to do machine learning? So the obvious thing to do, of course, is to use parking lots. So anywhere, whether it's rural or urban, is going to have access to this um, type of images. So you can see at the end there, that's the person who was flying it. That was one of our interns. So each year we take about a half dozen interns and teach them how to create mobile apps for drones, or blockchain, or robots, or whatever we're doing. But anyway, last year we took it a step further and added some machine learning to their task list. So basically, the first month they'd learn how to do Android. The second month they'd learn how to do iOS. In the third month, before they'd go back to college, is to get them to put everything together in do some machine learning with TensorFlow, and get them to do a similar app to this. But because they've only had a few months, they've already got up to speed. Oh yeah, we had to do drone SDKs too as well, and they had to get up to speed with the drone SDKs. We really didn't have much time left for the AI part, for the machine learning part. So we were really looking at ways to simplify things. When we did this the first year, we were using GCP, Google Cloud Platform, and they basically just spent weeks configuring the cloud computers. It was a complete nightmare. We also had lots of issues with images getting lost, labeling getting lost. Labeling is really boring work, so the last thing you want to do is lose all the labeling, so you have to do it again. You do not want to do labeling twice. You want to find ways to do it quicker. And I guess that's what we're trying to do here. So essentially what we want to do is we want to take videos, and then we want to plug it in to our into our whatever system we're using. We were using RoboFlow to get it to chop the images, to get it to give us lots of get more images for the price of one image. So by changing the hue, changing the saturation, changing the angle, the orientation, and then we want to run the training and then quickly deploy it to a mobile phone. So we'll talk a little bit about how we took a lot of those shortcuts. So there are 4 steps in creating our parking lot app. So we have labeling, training, deploying, and testing. So labeling means, easy for me to say, labeling means literally putting a box around each of the things you're trying to label. So it's a person, it's an umbrella, it's a balloon, whatever it is. It's a shark, it's a sheep, it's a car. So it's an incredibly manual and boring process, but we do have a great shortcut. So in the system that we're using, I mentioned it before, RoboFlow, but there's others out there. There's the Hive.ai, and there's Make Sense. But basically what it does is you label the first 100 images of what you're doing, and then you use that to train the rest of the images. So it's a great shortcut. So then instead of it becoming a labeling exercise, it's like a quality control exercise, because you're correcting the bits that that didn't identify the cars correctly. And then when you're finished with all your labeling, you use the correctly labeled 1,000, 5,000 images, and then you use that to train your machine learning model. So training is the action of presenting all those label images to your neural network. That's the input layer thing that I showed you. And we use Google's TensorFlow for our training, but you could use Facebook's PyTorch, and there's lots of other ones out there. Microsoft Azure is a great model too as well. Deploy means getting it onto the phone, so we use TensorFlow Lite for that. And then testing means finding out about all these things you didn't do right, like not taking pictures on a rainy day, or taking it from the wrong angle, and then you have to go back to step 1 again. So yeah, the point here is this is an iterative process. This is not a one and done. You have to keep going and going and going, and make sure it gets better and better each time. If somebody's going to use your model, is going to use your app to fly over cars, parking lot to count their cars, well then why don't you use that data? Why don't you have a workflow to take that data back into a process, so you can use that for training it to make the next version of your app better, assuming you have permission from them. Okay, so we choose to count cars. It's just really, really easy to get drone video parking lots. That is not usually the case. So, like I said, we started off with sheep. It was really annoying. There's also quite a few um, car uh, parking lot data sets out there, so you can just use an existing data set that's already labeled. There's no reason why you can't do that. If you had to label 5,000 images with multiple cars, you'd lose your mind. So we label about 100 and then use the label assist to try and guess the cars and empty spaces in the remaining, 4,900 images. I don't even think you need 5,000 images anymore. There's a new version of the neural network that we're using. I guess I should say that. Back in the day when I was doing this in the 90s, you wrote your own neural network. So you basically figured out what your back propagation layer was, and then through writing just basically an array programming and array manipulation, you wrote your own neural network. You don't do that anymore. So there's hundreds of different neural networks out there that people have given us. So we started off this. We were using MS Coco, Microsoft Coco, and then MobileNet, and we're now using YOLO v5 on this. So I think we're fairly up to date. We were using YOLO v4, but we updated it the other day. So, but that's the cool thing. So basically, what you're doing is somebody's giving you the model, the spreadsheet, and you're just putting stuff into the spreadsheet and getting it to do its calculation. Use RoboFlow a lot. I really like it. Basically allows me to organize all my images, make sure I can invite the right people, make sure I can see what kind of labeling they're doing. Hopefully nobody's taking any shortcuts or falling asleep when they're doing it. And then we also have the label assist, which basically you just do a couple of 20, 100 images and then get it to do the rest of the images. And then we can figure out what our precision is. And then it has a webcam in here too as well, so you can just test it yourself. If instead of before you go to the putting it TensorFlow Lite, you can just check it in the webcam, which is pretty helpful sometimes. You can see if you're miles off and you need to go back to square one again. What else? Yeah, there's lots of things where it will change the hue, change the saturation, change the orientation. So even if you only have 1,000 images, it quickly grows to 2,000 or 3,000 because it'll copy the image and change the color slightly, and bingo, you got a new labeled image. As I said, there are other versions out there because RoboFlow is not free. So there's the Hive.ai and MakeSense.ai. I think MakeSense.ai is free. I haven't used it myself, but I just want to give you some examples. Mohammed from RoboFlow saw that we were doing this, and he gave me some really good data sets that they already have on RoboFlow. We actually have a couple of data sets out there for the sheep. So we put out labeled sheep and labeled cattle. So if that's what you want to do, they're already out there. So big thanks to Mohammed for doing that. And then instead of us using GCP, we are using Google's Colab, which is an in-browser machine learning platform, which is no configuration. It's just amazing. When we were doing this in GCP, it was driving us crazy. It was almost annoying as the labeling. Also, if you pay an extra $10 a month for the Google Pro, I see there's a Google Pro Plus now, but I'm just doing the $10. I think the Google Pro Plus is $75 a month. But for the Pro, they'll throw in a dedicated access to TPU for faster training. Excuse me, it is still slower than the Google Cloud Platform, but it requires little or no configuration. In GCP, you're basically using banks of TPUs, but in this one, you're essentially just using it using a GPU or a TPU. So if you're doing a huge model, you probably want to go for a Google Cloud Platform. And also, yeah, I do remember that Google Pro Plus, it will run it in the background. So if you want training, you have to keep it open all the time. So, sometimes it gets disconnected for whatever reason, network goes down. Your browser, your machine just decides to freeze. But if you use the Pro Plus, then it will run in the background, which is great. You're going to need some basic understanding of Python to work with this Colab. And then we did steal this from RoboFlow. This came from a RoboFlow blog, and you'll see it's all YOLO v4. It's now v5. We changed it to v5. And that's in the source code, which is at the end of this presentation. Presentations are always up on SlideShare, and then the code is just up on GitHub in a public repo. So the parking lot app, it's parking lot YOLO v5 PyTorch. I don't know why it says PyTorch. We weren't using PyTorch. I thought we were using TensorFlow. I'll have to double check that. But this does borrow heavily from a RoboFlow blog on YOLO v5. Maybe we were using PyTorch because maybe that's what was in there. But it's all of the code is there, and it's pulling from RoboFlow, but you could get it just as easily to pull from Google Drive. There's no reason why you couldn't do that. If you don't want to use RoboFlow, or if you're using something else. It'll mount, the Colabs will mount to your own Google Drive, so you can put your pictures up on, labeled images up on your own personal Google Drive, and then just hook the Colab to that, and then get it to run from there, and then just follow the same coding as they have in this parking lot Jupyter notebook. Excuse me, got lost there for a second. Okay, and then when we want to deploy it, there's a couple of ways of deploying it. I'm going to go old school here. Here you can see this is our labels file. It's called cocoa.txt, which is that's referring back to when we were using MS Cocoa, which is about 3 years ago now. We could probably should change that now, but you get the general idea. And then the Model TF flight. So what you're doing is you run it through this Jupyter notebook on the Colab. When it gets to the end, it's going to export a TF-Lite file, download the TF-Lite file, and then you basically put it into your Android app. So this is the whole Android app, parking lot app source main assets, and in the assets folder we have our label file and our TensorFlow Lite file, which is the YOLO 5 in this case. If you're looking for information on that, Lawrence Moroney's book, AI and Machine Learning for Coders, is exceptionally good. He also has a Coursera course, although I saw the other day that that's changed. But this is, it's a book's a book. It's not going to change. Go and take a look at that if you can't find the Coursera course. It walks you through how to take a TensorFlow Lite file and export a TensorFlow file, convert it to TensorFlow Lite, and export it to your Android phone. And this is the code that detects the cars. So we split up the incoming. This is the YOLO v5 classifier. So it says, okay, within the assets, find me the model file, the labels file, and then whatever the input size is. And this is the code that is doing the actual detecting. So it will be in parking lot app source main, Java, although everything's in Kotlin. So when a texture view surface is ready for use, so the drone video feed in this case, you use it to initialize the codec manager. And also we are setting up a machine learning classifier to track each frame sent to the surface texture. So for car object detection. And the results of the classifier will produce colored boxes around the cars found in each frame, along with percentages corresponding to the prediction for each car. So couple of meetups back, we went through all the DJI Kotlin examples. There was 10 examples. One of those was how to fly a mission. So an automated flight, and you would use the code to set up an automated flight. In this case, there's two sets of code in this parking lot. One is for the DJI Minis and the smaller drones, Sparks, which you would use virtual sticks to do the mission. And then it also supports the M300 because we use this code for something else. So we also have some M300 code in here for doing a mission. And then you test. So basically you take it out of flight and see what it can do. It's just doing it in real time. There is code in there for calling an OpenCV backend, but I'm not going to talk about that too much today. Um, but you can see it's doing pretty well. This isn't running an automated flight. This is just somebody flying it. So it's giving you how many cars are there. So the idea would be that you would fly in a consistent fashion, maybe once every 15 minutes over the parking lot, and it would say how many spots were empty. So then you would send that up to some backend API, and you would push that out to a sign, so you could see if you could tell people if there were any spaces or not. Okay, lessons learned. Wow, wow, wow. There were so many lessons learned on this. Oh my God. You might you never have enough input images. I might change that now. Yodo V5 is great. We're getting away with a lot less images and getting pretty good accuracy. So in when we were using MS Coco, we would say start with 5,000 images. I'd say you can probably start with 1,000 now. So I don't know, maybe an hour or so of video over multiple parking lots. So that's why we choose cars in parking lots as an example, because it's much easier to get the data. Be creative on where you get your video or images. I talked to somebody at a conference a while back who was using webcams from Times Square to get lots of different pictures of people and cars, which I think is a great idea. So, lots of webcams out there might get you different things. We're trying to do some shark footage, so we were out on YouTube trying to get lots of sharks. We were also doing, you might want to do synthetic data, so we've tried that recently with a company in Israel, where they provided us with 8,000 images of computer-generated sharks for something that we were trying to do. I know that Lawrence Moroney has talked in lots of different blogs that he's written about, even synthetic images can work surprisingly well to train a model, which is later used in the real world. He does something with horses. I don't know. The jury's out for me at the moment. I'm not convinced. Animals move, second point. So you may end up double counting. So use a thermal camera and take the pictures at night if you can. So when we were counting sheep, it was, the drone would spook them. So it was kind of always a trade-off between having the camera low enough so that you could see the sheep, and also not having it too low, because you'd spook them and they'd move all over the place, and then your count would get out of whack. But however, people count cattle, large, huge herds of cattle, and they count them from a helicopter. So with a pen and paper. So you got to think about, what is the accuracy here? What are you looking for? So animals move, yeah, just assume that you're going to count 10% more if they move a lot. Thermal cameras work great, but of course, if they're sheep or cattle, then during the winter they're going to be inside anyway. So maybe just use a camera with some image detection as they walk in. Maybe that's the best way to do it. So we'll get to that in a second. Choose the right hammer for the job. Limit the conditions. So go specific, not general. So what do I mean by that? So when we take our parking lot, you'll notice that it's always from the same straight down nadir angle. So we're not taking it from the side. We're limiting the conditions. We're going to make sure that our automated flight is always flying the same pattern. So we're going to limit what it is. We may just do it in rainy days, or we'd have to do a new model if it was snowy days. There's a lot that you've got to make sure that certainly for a proof of concept, you want to go as specific as possible. So know when to choose the right hammer for the job. So know when to go VTOL, that's vertical takeoff landing, or if the object is big enough, satellite images. So, if we've been asked a bunch of times to do large herds of cattle, over many hundreds of acres. So how do you do that with a drone? Because the battery's going to run out. So then you basically go VTOL. So then that's going to be 20 grand, up to 100 grand for a VTOL. And then, maybe you could do it with satellite images. So I know that there's an example from a white paper from Maxar about how they counted elephants using satellite imagery. So just make sure that you're using the right hammer for the job. If it's hundreds of acres, chances are a Phantom 4 Pro V2 is not going to work. And then also ethical issues. So we don't do any training using pictures of people's faces. If we are doing anything with people, we will just go with thermal images because thermal images can't be racist. So be careful about what you're doing. Ethical issues. Programs don't lie, but humans make programs. So I just be very cautious, especially where I'm based in Detroit. There's been some amazingly bad examples of people using facial recognition and not using their brain, just assuming that the machine is right when it wasn't, and then somebody got arrested for no good reason in front of their family. Okay, and then OpenCV. So next steps would be, okay, so you have this in real time, but it's not really much use to me because I want to know how many my parking lot has got 1,000 cars in it, and I want to know how many are empty. And I want to do that on a consistent basis every 15 minutes. How do I do that? Well, you're going to have to stitch all the images together and get a total count. So OpenCV is what a lot of people use. Pretty easy to set up. OpenCV.org. And then you have to create a REST API or a Go API, a REST API in Go or Python or whatever your favorite language is, C#, Java, to be able to ingest the images and stitch them together. We've done that a couple of times now for our cattle, for our sheep. And then essentially what that does is stitch the images just into one big giant picture, and then you can run TensorFlow like that again, and then you get a total count of many's available. Problem with that is the stitching can take time, so you're going to need a big machine to make sure that it can do the stitching quick enough, because people come in out of parking lots really quick. There are other examples here. This is one we did recently, which was for weeds. So we trained the instead of using cars, we were training it on pigweed. So the pigweed would basically, the farmer wants to know where to spray, but they don't want to spray everywhere for pigweed. They just want to be very selective on where they spray. So our object detection was looking at all of the field and detecting where pigweed is and where mare's tail is, and then the sprayer would come along later with the coordinates and then spray exactly where it needed to. So it's much more environmentally friendly, saves money for the spraying too as well. Some resources. So the code is up on github.reese parking lot app. It's all up there. The Jupyter Notebook is there, so you would download the Jupyter Notebook, you'd open up the Colab, and then you basically would import it into the Colab and start running it. The Lawrence Moroney's book on Amazon, if you want to take a look at that, highly recommend it. Might be a bit outdated now, but certainly for what we're doing here, it's not. And then OpenCV.org if you want to think about what you want to do on the stitching side. So if you want to get a total count instead of just a real-time count that you're seeing through the camera on the drone. Okay, I think that's about it. Thanks very much.